Okay, so let's kind of walk through this. Now, these are the notes you should have taken yesterday. We had a lot of postulates we covered yesterday. Perfect. That's it. Okay, this is one of the postulates we covered yesterday. This is the ruler postulate. We're going to be measuring things eventually, not in this chapter test, but this says anytime you have a number line, any hash mark that's on it has a real number associated with it. That was pretty basic. Again, I'm not going to give you enough time to write this down in case you were gone yesterday, but you can always go to the website. I have built PowerPoint on there, so you can go check it out. I think the website is up to date. Every video is working and simple fixes, but it's all back online, so you can watch any videos you want from the previous chapters. Stuck with me for a while. But anyway, postulate 2.9. This one we really hammered down yesterday. We did, I think, 2 examples of this one for sure. No, we did one. We did one with angles, didn't we? We did one example of this where we did like a proof using segment addition where you can add segments together. This will be a big part of the problems we do today. A big problem, like a big part of it. So keep this one in mind. It's called segment addition. You can add 2 small segments together to make a bigger segment. Now, what we're going to eventually do is we'll apply it where you can add more than just 2 pieces. You can add 3 to make a whole thing. So that's what we're going to be eventually looking at. Okay. We talked about yesterday, we did the protractor postulate. That was one that you had to draw yourself yesterday, where if you had, a ray where you associate it with 0, and you have other rays drawn on one side of the line, you can associate those with numbers, real numbers. So like for instance, this started off at 0, and eventually counted up to like 146. That's what we talked about yesterday. That they have real numbers, that's how the angles work. The one thing I wanted you to take from this was that we're going to be needing a protractor, because there's going to be problems where we have to measure angles and stuff. So that's going to be something that you need to start finding it, or you're going to have to buy yourself a new one. Because we're going into angles. I mean, that's something we're going to be going into with a lot of these properties and shapes coming up soon. Other than that, knowing that your angles can be drawn 2 different ways. They can be facing the right or the left now, not just always standard position. Like this problem is, this angle over here is facing standard, this one isn't. If I'm going A, B, C, that's definitely a large angle, so it's using the outer track versus inner track. And the last thing we finished with yesterday, I believe we did a problem with this yesterday where we did a proof, in an algebraic proof style, where I gave you 2 angles, and you had to figure out why they added up to be 180, I think. And this picture does not look like 180. It does not look like a linear pair or anything like that, or supplementary, but, I just made up numbers where you can add 2 angles together to make a bigger angle, okay? Again, check those postulates out. These postulates, these 4, are fair game for the test for vocab terms. The reason being, they have names. Like, they have to be fair game. Other things you can do, like midpoint, the word congruent, perpendicular, linear pairs, supplementary. Those are words we've definitely been using. Segments, lines. Just trying to think out loud of things we've talked about in this class, this chapter alone, that, words that should be on a test. Okay, we're good so far? Okay, first geometry proof, here it is. I even hinted at these yesterday, here it is. So I think I have 4 or 5 picked out today that I want to go through today. So these are ones I would like to write down. I'll give you a little bit of time, you can write this down. We're going to try to prove the conclusion of that conditional statement, it's an if-then statement. We're going to try to prove the then part, the conclusion. That A, C, and B, D are the exact same pieces. That they're congruent to each other. Now, these are very, very different than algebraic proofs. We're not trying to prove that X is 7 or X is 50. I think that was a problem we did yesterday or something like that. Now we're actually going and doing full-on geometry proofs. These, for some people hate these. They just don't get it. They don't like it. This is something that you just got to get used to it. It's just like the algebra ones. You guys got a lot better at algebra ones over, the week that we've done it. Well, we're going to spend the next 3-4 days doing some of these now. I'll add properties here and there. Okay, everyone get a chance to write it down. Okay, we're gonna use the picture eventually. All right, how do you start a proof? Good. So what are we giving on this one?
AB is congruent to CD.
Yeah. Step one, AB is congruent to CD. That's what we're given. Not a lot. That's pretty much about it. Now, what that means though, is that on step number 2, we probably should define the word congruent. Because that was the weird symbol there. This one, we're actually gonna follow that pattern over there, define that word. So on line number 2, that means that when I measure AB, notice I'll have the bar off of it, that means I'm measuring it with a ruler, that's equal to CD, the measurement of that. And again, the reason why, this is the definition of congruence. Now why I have to state that is because in line 1 they use that symbol. I probably have to tell you what that symbol means. Sometimes they say the word midpoint, we'll see that in some of the later problems we do. We probably should define what midpoint means. It means 2 things are equal to each other. Now eventually, I'm gonna actually mark what that means. AB and CD are the same. Okay, so those 2 parts are the same. Fair enough. Eventually what I have to prove is that when you add certain sticks together, they're gonna make the same thing. So they're gonna make AC here is gonna eventually equal this whole piece, this thing, is gonna eventually equal this thing over here. So I'm gonna have to add pieces together. So I need to do a little bit of segment addition. Okay, so I'm gonna have to add some sticks together. So let's talk about that. So on line number 3, what makes AC? What are the 2 parts that make AC?
AB, BC.
Yeah. AB plus BC should equal AC. Agreed with that? They should be the same. Like that thing adds together to make AC. We'll get to the reason here in a second. And the other one, I'm gonna put this in green just so I can color code so you guys can see this. These 2 should add together to make BD. So, because that's the other stick. So I'm trying to prove that the black piece and the green piece are the exact same. That's what I'm trying to prove in the end. So this is BC plus CD equals BD. And the reason why this works, line number 3, this is segment addition. I can add segments together as long as they're in a straight line with each other. Segment addition postulates. If you want to say postulate 2.9, fine. I don't really mind that. I just say segment addition. So eventually I need to prove these 2 things are the same. That's what I need to get to. I need to get to that. I don't know that that's true right now. I know that I've added segments together to make AC. I know I've added segments together to make BD. But I have no idea if those 2 are equal, because that's the whole point of what I'm trying to get to. Okay, this is the part that is going to be a little weird for people. What I'm going to do is I'm going to be introducing a part. Do the green and black items, do they overlap anywhere? Where do they overlap?
B and C.
B and C. Does everyone agree with that? BC is the exact same piece to both parts. Okay? So on line number, this is going to be line number 4 here. Now this is going to seem a little weird. I'm going to say that BC is equal to BC. Now I know that seems really weird. Now why I say that is because I noticed on the picture that the black segment overlapped the green segment right at BC. BC was the same piece in both sides, this piece and that piece. So step 4, this is called the reflexive property. We talked about this at the very beginning of our properties. Reflexive is when you set something equal to itself, like just a mirror image. Why that's important? Sometimes it's important to establish that certain things are equal on a picture, because some people won't notice that they're obvious. Because what I'm going to do, I only have 2 more lines to go here, and now this seems a little weird, is that now that I've established that BC is the same on this left stick and the right stick, the green and black, I can now add this piece right here. I can add BCs I can add it to this thing, because you agree that these two things are equal to each other. Okay, we even said that in line number 2, that A, B, and C, D are the same. So what I'm gonna do is I'm gonna add B, C to both sides of that. So watch this. So on step 5, now this seems a little weird, I'm writing the part in red down. In fact, maybe I should color code that. I'm writing the part down in red. So AB is equal to CD. Now let's put a little space there. Okay, so that's still the part from part 2. That's the second sentence here. But what I'm gonna do is I'm gonna add equal things to both sides. So I'm gonna add BC to this side. I'm gonna add BC to the other side. What is that when I add things to both sides? What is that called? You just magically add to both sides. This is a property we did for algebra. You add to both sides. We did the other day.
Additive property of equality?
Yeah, you can just add things to both sides. You're absolutely right. So step 5, this is the add property of equality. You can do that for geometry shapes. You can add things to both sides, property of equality. As long as you do it to both sides, that's why it's a property of equality. Do you agree that I just added BC to both sides of that red part? One on line up above. Now why I can do that, because it is a property of equality. I'm adding the same thing to both sides. That's why in line number 4, I established BC is the same thing. So I can add it to both sides. On that line number 2. Now, why I wrote it that way, is because this is my final line now. This is my line number 6. We're gonna be getting down to, I mean, it's getting to the point where I can prove what I need to. What is AB plus BC equal to?
AC.
That's AC. Does everyone understand that? This makes AC when you add those two 6 together. We said that in like line number 3, by the way. AB plus BC is equal to AC. What's BC plus CD? What do you get when you add these together? BB. Okay. You said that earlier. So what I'm doing here is I'm substituting, I'm plugging things of equal value back in, substituting their answers in. So what I've got to is that AC and BD are equal. So if they're equal, what does that also mean?
They're congruent.
They're congruent, and that's the whole point of this proof. So this one actually took me 7. I took an extra line than what the book did. The book didn't have this, by the way. I put that in. I was just doing that so it helped you out why I can just simply add something. Line 7, AC is congruent to BD. And that is the definition of congruence. That they're equal in size, shape, and measure. I already said they're equal in measure. Not bad. Now, I did throw line number 4 in there. The book did not have line 4. I threw that in there to establish that BC is the same in both sticks. Some people kind of see that. So I can add it to both sides all of a sudden to this line up here. So it would have been a 6-line proof. But I think it was kind of nice that we established BC and then you added it in later, so it makes more sense. Now, I know this seems tough, right? Because it's not algebra. It's not that whole process that we did over there where your givens, you talk about a word that you've used, you set up your math formula and you solve for X, right? It's not doing that. You have to, this is a puzzle. You have to think about, okay, what did I start with? What's something obvious? Maybe it's using segment addition or angle addition. That's really the only 2 we ever use. Is there any parts I can use and substitute in later so that I can get these things equal to each other and prove that they're eventually the same in the long run? That's usually what we do. Now, can I tell you that there's one set way to do geometry proofs? No. Everyone's got a different method of doing it. That's the hardest part about teaching this. But you have to get used to it. You have to get used to, okay, I know what I started with, I know what I need to get down to, what's the middle ground? Usually the first 2 lines are kind of set. You know what you start with, you know what you have to define. At some point they're doing some angle addition or segment addition in there somewhere. But then I know what I need to end with. So there's only really 1 or 2 lines you have to actually do where you connect the dots. So maybe that's the best way to think of it. You're only really doing 3 steps by yourself. Everything else is kind of set in stone. You just have to figure out what's the logical way to connect it. let's do a couple more, because again, you just need to see more. You just need to get comfortable with, because just think about back to this. When you guys started your algebra proofs, when you guys were trying to prove algebra steps, prove that x is 7, it was tough, right? But you guys, eventually over a week of doing it, you guys got significantly better because we practiced it. You just saw more of them. So to get better at this, you need to practice. You need to just see the steps, make connections in your head, get familiar with the terminology that they use, get familiar with the property names, understand like how do I get to that answer eventually. All right, let's do another one here. Okay, this is one, I believe I showed you this one yesterday. I'll let you write this one down. I warned you this one yesterday. I think this one is going to be very, very, very similar to the last one, the one we just did. The only difference here is there's not like an overlap, so I'll probably use reflexive here. There's no overlap. They're kind of two different lines. We're talking about Vy and Vz, so that's like the two lines that are like making that triangle shape. So there's no real overlap. We'll probably do segment addition because they're talking about some sticks. We might, instead of adding double sets, we might subtract to get to like equal parts here. But again, how I'm thinking about this in my head is like, I know what they're giving me because I can see it on the picture, I can kind of understand the parts. And I'm trying to figure out in my head, how do I get down to what I'm trying to prove? So maybe let's talk about this out loud. So I'll let you write it down. Let's talk about it out loud, like the idea of what I'm going through in my head. Like how do I look at this problem? How do I know, like how do I map out the proof in my head? Because that's literally what I'm doing. Like I'm doing a very informal like structure in my head. Like this is what I see, this is what they're asking me to do. Because maybe this will make more sense for like the logic, the steps. And I'll try to color code with markers and stuff. I think that sometimes helps people to see this. All right. Some people are still writing. I'll wait for some people to get done here. Okay, so on this next part we're gonna do, I'll ask you to put your pencils down. That way you can just kind of focus, watch me, we'll talk you through it. I'll give you a little bit of time if you want to write that down after we're done talking about it to make more sense to you. But I want you just to kind of watch, because sometimes it's just nice to kind of just look at this problem and think about it, right? Okay, let's start with the first line. They're talking about a couple sticks being equal to each other, correct? Let's highlight it. I'm gonna put this in red just to highlight what they're talking about. They're talking about this stick is equal to that stick, basically. That'll be like one of the first lines we do in the proof. But let's highlight in red so you can kind of just see that in the picture. VZ is this thing. So they're saying this big piece here, that huge line, the diagonal line, V to Z, is equal to V to Y. Okay, does that make sense? That those two sticks are equal. They gave me that. That'd be like my line number 2 kind of idea. Line 1 is write all the givens. Line 2, just find that means that they're equal. Okay, so that makes sense. They're also saying, and I'm going to color code this maybe in a different color now. Let's go to like a blue color. They're also talking about that WY is this piece, this little chunk right here. That piece, WY, is equal to XZ, this piece. Okay, does everyone see that? Those two are equal. Okay, fair enough. Those pieces are equal. I color coded. What we're trying to prove in the end is that VW, this piece, is equal to VX. Okay, that makes sense. So here's what I'm thinking about in my head, like logically. I know the big red pieces are equal, the big pieces. So probably what I'll do, I'll start with that fact, I'll start with that those are equal. We'll talk about, segment addition, like what adds to make those pieces. Okay, and I can substitute those so that they're equal to each other, those big pieces. And probably what I'll do is on one point I'll set this equal to this, right? And what makes this thing is these two pieces add together. What makes this thing is these two pieces added together, so I'll set those equal. And probably what I can do is I can subtract these things off of it. Does that make sense? Because if I take away parts that are equal, it's called subtraction property equality. It's like if I subtract 8 to both sides. If I subtract the VW and I subtract the XZ from both sides, I'm left with the green parts, and those would end up being equal to each other. That's what this is like the logic I'm going through my head. It's like, I know that I need to get to those pieces being equal, so I'm probably gonna take this, and subtract these things off, these two blue pieces. That's kind of like, that's the whole proof in my head. I can already kind of see the outline of it. That's what I do before I always sort a problem. I look at the picture really kind of challengingly. I try to see, okay, what do I need to get to? I need to get to these two pieces being equal, so I'm probably subtracting things off of it to get to the smaller pieces. So let's do the proof. So pick up your pencil, let's go through this. So step one, what do we always have to write on the proof?
Given.
Givens. We're given a few things. We're given that VZ, that stick, is congruent to VY. So VZ and VY are the same, they're congruent. We're also given that WY is congruent to XZ. Okay, there's my given. Okay, fair enough. We're given that. Okay, line 2. If you're looking at my little outline over there, we probably should define what those little symbols are. What do those symbols mean again?
Congruent.
Yeah, they're congruent. That means they're equal, right? So that's going to be on my line number 2. And the reason why I'm doing this is because they have the symbol, I have to define it. If they said any other words, I'd define what those words are if I needed to. So line number 2, that means that VZ is equal to VY, if I measured it. WY is equal to XZ. And again, this is the definition of congruent. That's those little symbols with the equal sign with the little squiggly above it. It means that they're equal. So far so good? Makes sense, like how I'm doing it? Step 3, let's set up some formulas. Let's do like segment addition. Let's add some sticks together. So what makes VY up there? What are the two parts that make VY, the part in red? Say it again? YW and? Okay, YW and WV. Those parts add together and it makes all of YV. Or VY, however you want to say it. Does that make sense? If I add those two pieces together, that makes YV. That's the top piece in red. YW, WV makes YV. And again, you can make that in any order. If you want to say that's VY, maybe you like it alphabetical, that's fine with me. They mean the same thing, by the way. Okay, let's add the bottom one. What makes the bottom two add together?
ZX and XV.
ZX, XZ, or XV, and those add together, and that makes all of what? ZV? Again, you can make that VZ, I don't care what order you put that in. And again, that's segment addition. I'm adding the two bottom chunks, the blue and the green, that makes the big red piece. That's segment addition. All right. So what I'm going to do now in step 4, because these are like the basics, right? We talked about, what was given, we did a little defining what a word meant, we talked about segment addition because we needed that. What I'm going to do now, and this is going to be a little bit more different than the last problem, I can immediately jump where I can set this thing equals to this thing. The reason why, I already know that these two things are equal. That we even said these are equal in this line up above. VZ, that's this thing, is equal to VY. They're equal to each other. So I can set them immediately down and go right to it. So I can set those. So I'm gonna do that. So we had VY, VZ, these are equal. I'm gonna substitute these parts in. So in step 4, this thing is going up here, this thing is also going up here, and I'm gonna just set them equal to each other. I don't care the order you put them in, here we go. WY, or YW, WV, that's equal to ZX and XV. I can immediately set them equal to each other. Now, how I did that, because I knew that these things were equal in line number 2, right? They even said that's right here. So I'm just substituting this mess in for there and there. Yeah, they're on the wrong side, but they're fine, they're equal. Okay, I just substituted. Make sense how I did that? How I substituted those parts in for the YV and the VZ up above. And I put them out of order, they're probably should have been switched around, that's fine. Okay, now remember, the whole goal is to prove that this piece right here is equal to this piece. That's what I'm trying to prove in the very end. I'm trying to prove that those are congruent, those are equal. So here's what I'm gonna do. And I know this seems a little weird. I'm gonna subtract equal parts off of this step number 4. So I'm gonna do a little subtraction. I'm gonna subtract equal pieces. What parts are equal from line number 2? Yeah, YW and ZX. Does everyone see that? Those parts were equal in step 2, right? I'm gonna subtract them off from both sides. I'm gonna subtract a YW off, and I'm gonna subtract a ZX off. And again, the reason I'm allowed to do that, they are equal in line number 2. I'm doing the subtraction property of equality. I'm subtracting things of equal value from both sides. If I subtract them, what do I get? WV is equal to XV. I subtracted equal parts off. So my property that I just did the subtraction property of equality. Prop of EQ. I subtracted to both sides. Now, if they're equal, what does that also mean?
They're congruent.
They're congruent, and that's why I had the final line. So line number 6, usually there's a 6-line proofs. I'll put it over here, line 6, dot, 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 here's what I'm trying to get to. Since they're equal, that means that VW is congruent to VX. That is the definition of congruence. Because the reason I can write the definition of congruent is I know they're equal. I can put the bars above them, the sticks have to be the same. And again, you can switch the letters around, because it doesn't matter the order that you write names, they're the same name. Makes sense how I did that. It was basically walking through the exact outline that I had in my head. That I'm gonna set, those big sticks equal to each other, subtract the small pieces off from both sides, and that will leave me with the green pieces up and trying to prove that are equal. Now, the only part that's a little controversial was probably step 4. I kind of put things out of order. Because if I was really substituting these incorrectly, this part here would go over here, this part would go over here, so this step would have been backwards. The only reason why I had them switched, I did symmetric, is so that it came down to the right answer, what we're trying to look for. So I probably should have a symmetric in there, but it's not a big deal. And again, the reason why that step 4 to 5 works is because I subtracted equal parts from both sides. I've definitely seen the book do that differently, where they substitute, like they take out ZX, and they'll substitute a WY in there, and then they'll subtract WYs from both sides. So they're showing that they're actually subtracting the same thing, so it doesn't get too confusing for you. But for me, I understand they're equal, I can subtract them from both sides. They're equal parts. All right, I'm gonna put the next problem on the board. I'm gonna have you write it down, and this is a problem that I'd like you to try to work on in your little pod, your little group. And let's see if we can kind of fiddle our way through. This is our last problem of the day, by the way. As I said, I only had a few that I wanted to go through today. I even showed you all of them yesterday. This is our last problem of the day. It's the last geometry problem, because again, I want to practice these kind of over and over and over. Eventually, hopefully, by the end of the week, we can start reviewing for the chapter test if we're almost done. Unit. Alright, here's our last problem of the day. Last problem of the day. Does anyone still need that proof, by the way, or can I get rid of it? Anyone still writing it? Alright, I'm gonna erase it. Looks like we're good. Okay. Okay, it's our last one. I'd like you to kind of go through, let's see if you can figure out some of these parts and how to do it. Let's see if you can talk through with your neighbors. This is one that I just want you to kind of experiment with. Let's see if you guys can maybe work on this, and if we need to, we can take it home and we can bring it back tomorrow and let's see if we can figure this out. I'm gonna say that this one's gonna be very, very, very similar to the one, not the last problem, but the problem we did before. We're gonna add segments together that kind of are like overlapping maybe. It's close. There's really no overlap here. See if you can figure this out. Kind of a good one. This is one that I might just let you try to work on, maybe bring it back tomorrow. I think it's maybe just one step we just need to work on this one. This would be kind of a quasi homework problem, even though it's not homework. I'm gonna stop the camera there. I want you guys to work on this. I know we only have about 5 minutes left. This is a good thing. Like, work on it and see if you guys can fiddle your way through it, or come up with, like, maybe it's not, you don't have the perfect proof, but you can explain how you're going to do it.